Okay, gang, this is Miss Butel, and I am coming to you today with 2.8 inverse functions, numerically and graphically. All right, these are the notes that we did in class. If you will pause the video, you can fill these in. One thing that I will tell you, either while you're filling them in or you unpause, is that last year I related this to the kids in this way. So if I make a function 1, 2, 3, 4, 5, 6, so 1 and 4, 2 and 5, 3 and 6 go together. The inverse function, it just flips these, so it's 4, 1, 5, 2, 6, 3. All right, so this is something easy really to see. And then this is this year's take on this. This is the way we're looking at it. We may not have seen this last year. This notation may be new to you. Or last year, this is a throwback from last year. If f of x and g of x are inverses of each other, then f of g of x is the same as g of f of x, which is equal to x. Okay? Next, you had to go in down here and you had to fill in, this was the relation, and then we want the inverse relation over here. So if you notice what I did, I took the y values, put them in the x, took the x values, put them in the y. Is the original relation of function justify? Well, honestly, all I have to do is look at these values and see that none of them repeat. So the answer is yes, because it says to justify, because for every input there is exactly one output. Okay? Is the inverse relation justify? First of all, I notice that I have a 2 here and a 2 here. So this 2 has a value of 3. If I just graph the 2, I have a value of 3 and a value of 6, which means it does not pass the vertical line test. So that means the answer is definitely no. No, it's not a function because there are two distinct outputs for one input at 2. Okay? All right, so the next thing, and we did this in class and it went really quick. So f of -1 is, so you get, this is your x and your f of x. So the function of -1 with respect to, or the function at 1, -1, excuse me, is -3. So that's your answer. And then it says up here, let g of x be the inverse. Well, I don't think I have to rewrite this whole thing to know that this is kind of like your x and g of x for the inverse function. So when I am on g, when I'm here, I go to the -1 and it goes to 0. So real quickly, I'll fill these in. 4 matches to 3. 4 goes to 5. F. Okay, now the last two were the two that surprised my kids the most, because when you take g of 0, this piece right here will give you 2, and f of 2 goes back to 0. So what this does, it supports exactly what this is saying up here. It's just, instead of the f of the inverse of x, we have f of the inverse of 0, which gave us 0, or -3, which gave us -3. Okay? All right, so pause the video, get these filled in. Just so you know, if I'm taking notes and I'm trying to write fast, I will write VLT for vertical line test and HLT for horizontal line test. I will not use those when I'm making out a key for a test. I will always write it out. But just as a shortcut in my notes, you may see that. And a big takeaway here that may be new, functions that are not one-to-one can have a domain restriction so that part of your function has an inverse. So it is possible to have an inverse even when it normally doesn't happen. And also note that the domain of the original function is the range of its inverse. And the range of the original function is the domain of its inverse. Now, I just showed you up here at the top how I did these and just flipped them around. You may want to notice that I put, if needed, you can create a T-chart and its inverse. This helped me. It's up to you. You can try it. Okay. So the next one. So on this one, I have graphed part of what I know. I want to show you that I graphed, you see these 3 points, -2, 0, and 1 that are here? I went ahead and graphed them in green. I don't know if mine look all the same thing or not. And then I found some distinct points that look like they make, because looking at this, I'm not sure how to connect these 3 in the middle to graph this. So I went over here and I said, well, this one looks pretty good. It's -1, 2, and this is 1/2, -1/2. So what I'm going to do is I'm going to go back and I'm going to graph these, but I've got to flip them. 2, -1, -1/2, 1/2. Okay, so I'm going to see if I can graph this. 2, -1. There's 2, -1. Oh, look at that. I get to go right through the middle of 1. And then -1/2, up 1/2, which is going to put me there. Now, be careful. I'm only going to connect the ones that are in green, but this looks like, this goes over toward the away. Okay, so this looks like this comes in like this. This actually bends here, comes through this up a little pass and down. Okay, if you want to check how good your function is, and I did not have to go through that, it probably does something more like that. Not really. Oh no, it had to go through that. Yes, I'm as crazy as I thought I was. It was closer to begin with. All right, we'll get rid of those lines. We'll check it. I've got a post-it note right here, and let's see if this will go through all my lines. If I am dead on, I should be able to have this diagonal line right here that's invisible, but I just made it visible. Okay. If I have this diagonal line, then all my intersections, you can see I'm off a little bit right here, but my intersections should all hit there. All right. So I got relatively close. Notice the inverse is not a relation, so that's a no. Is it one-to-one? No, because this did not make a function. I just said it's not a relation. The relation's not a function. Excuse me. And is it invertible? And the answer is no, because the inverse is not a function. Still, it's not a function. Okay, so if I go over here and do this one, you may want to get started. What I did do is graph the two pretties. And pause this, you can do it yourself. What are the pretties? They're the x-intercepts. Well, there's a couple more that aren't really uglies. Look at this, -5, -7. All I have to do is flip it around and I go -7, -5. And then I'm going to go -2, -4, that's here. And then here, I've already got that one, I need 7, 1. There we go. So this is coming in from this side and out, and this flips and goes out the other side. All right, and again, if you wanted to check, here's the line that I flipped it over. Pretty good. This one's probably the prettiest one that I did on the page. I would say that's a good one. Is the inverse relation a function? The answer is yes. Is G one-to-one? Well, yes, because both the original and the inverse are functions. So yes. Is it invertible? Yes. And I got so excited writing that one, I left out the E. Look at that. All right, so in this next one, they gave us the graph. I found the domain. It's a parabola, so it's all real numbers. And what's the range? Well, the lowest it went was 2 and off to infinity. Now, I don't care which way you write these. They're both correct. Is f a function? Well, sure it is. It passes the vertical line test. Look at that. Whoop, passed the vertical line test. Is it invertible? No, because it fails the horizontal line test. Well, look what happens when we say no. Is the inverse a relation? So I took this, and I can tell this is a little bit not the same. This one looks a little fatter than this one. Oh well, close enough. It fails the vertical line test. So nope, this is not a function. But look at the inverse domain. It's everywhere where x is greater than or equal to 2. Okay, or 2 to infinity, whichever way you want to say. All right, and then the inverse range, well, how low to how high does this go? It opens up slowly forever, so it is all real numbers. All right, notice these swapped. Okay, and that's what's going to happen here as well. So this is the graph from number 5, so all I had to do was repeat it, but cut it off where x is greater than 0, because look what the domain restriction is. All right, so once I had the domain restriction, then all I had to do was repeat the graph here, and I can see exactly what happened. So now the domain, well, this said x is greater than 0. It's telling me greater than or equal to 0. It's telling me my domain, or you can say 0 to infinity. The range is 2 to infinity because it's still the same as it was before. Is this a function, and is it invertible on the restricted domain? Yes and yes. Why is it invertible on the restricted domain? Because this passes a horizontal line test. You can tell it does not double up its value going this way. Now on this one, it passes, cover this up, don't look at it, it passes the vertical line test. Use any points that you need from here to here, or if you have to do a T-chart, use that. But I know how to graph this, so I've graphed it. And notice again how the domain and the range from a function and its inverse match up. You see that? And I'm going to underline it because I'm afraid it's going to make it disappear. Here we got greater than 0 or 0 to infinity, and there it's 0 to infinity. All right. Oops, I just totally threw a marker. Yay me. All right, so moving on. So this one, I know that 2, 4 is the vertex, or use a calculator. I stole the vertex out of here, so out 2, up 4, here's the original one. It's right here. And then, and this said the domain is x is less than 2. So even though I know the other side would have looked something like that, I don't need this side because it restricted my domain to be x is less than 2. Well, here's 2, so the domain had to go from there back. So when I turn around, okay, so getting the domain and range I can do of this green line. Okay, that's A. Is it a function? Well, of course it is. And is it invertible? Yes, it is, because this green line passes the vertical line test. So I sketched this in pencil, and all I did was reverse these values. Okay? Is the inverse relation a function? Yes. What is the domain and range? Well, I know from up here, these have to match. Okay? So I know that's what it's got to be, but if I don't, I could do a T-chart and say, what do I know happened here? I've got to go with the first one I start, and it's 2 and anything less. So I'm going to go 2, 1, 0. And if I plug in a 2, I will get 4, and if I plug in a 1, I will get 3. 0 is 0. So what is my domain restriction on this side? We haven't talked about that, but my domain restriction is actually sitting here looking at me. But look at what happens. 3, 1, 0, 0. So it was coming in. This would have continued to drop, but see how this is going down, 4, 3, 0, and anything below it? That's exactly what this is saying, negative infinity until it gets to 4. These are our x values. These are the y values from negative infinity up to 2. Makes total sense. So do I like these T-charts? Yes, they are extremely helpful. All right, so let's see. I'm on part 2, so I'm actually going to stop the video and you can do some of the homework.